Hello friends, today in the part of the program we will discuss about the architecture of 8086 microprocessor. The basic architecture of 8086 microprocessor consists of two main components, that is the bus interface unit and the execution unit. The bus interface unit has the address generation circuit, the segment registers which includes CS, DS, ES, SS, then it includes IP, that is the instruction pointer, then it includes 6 byte prefetch queue in which 6 bytes are fetched in advance from memory and are placed in this queue. Then the next part comprising the architecture is the execution unit. It includes general data registers, that is AX, BX, CX, DX. Then it has pointer registers, that is stack pointer SP, base pointer BP. Then it also includes index registers, that is DI and SI. It has also in it an ALU which is responsible for performing arithmetic and logical operations, and a flag register. Now let us discuss first the bus interface unit of 8086 microprocessor. The first part in it is a dedicated adder which is responsible for generating the 20-bit physical address. This adder generates the 20-bit physical address with the help of two registers, that is the segment register and the offset register. Then this bus interface unit includes 4 segment registers, namely the code segment, that is CS, the data segment, that is DS, the stack segment, that is SS, and the extra segment, that is ES. It also has the bus control logic and 6 byte queue in it. Now first let us discuss the segment registers. The segment registers are nothing but the 16-bit registers which are actually used for calculating the 20-bit address for microprocessor. Actually the segments are logical segments. The memory is not segmented, but it is logically segmented. That means the physical memory is such that it is continuous in manner, but it has been divided into logical segments. Now two segments can also be overlapped with each other. A single segment is of maximum of 64K size. Now if no segments are overlapped, then they are in continuous in manner, but few segments can also be overlapped. As you can see in the slide, the segment 0 and segment 1 are continuous, whereas the segment 1 and segment 2 are partially overlapped. Similarly, segment 2 and segment 3 are fully overlapped, and segment 2 and segment 4 are disjoint. Now each segment can have maximum of 64K value. The overall memory of 8086 microprocessor, which is of 1 megabyte, is divided into segments of up to 64K byte each. The 8086 can directly address 4 segments, that is 256 kilobytes within 1 megabyte of memory at a particular time. The program obtains access to code and data in the segment by changing the segment register content to point to the desired segment. Now let us discuss the various segment registers. First one is the code segment register. It is a 16-bit register. The code segment contains the base or the start of the current code segment. The IP register contains the distance or the offset from this address to next instruction byte to be fetched. The bus interface unit calculates or computes the 20-bit physical address by logically shifting the contents of code segment by 4 bit to left and then adding the contents of offset register to it. In other words, we can say the 20 bit address is calculated with the help of two 16 bit registers. One is the segment register and another is the offset register. That is, all instructions of the program are relative to the contents of CS register multiplied by 16 and then offset is added provided by the IP address. Now the next segment register is the data segment register. Again, it is a 16 bit register. It points to the current data segment. Operands for the most instructions are fetched from this segment register. The 16 bit contents of the source index or the destination index or a 16 bit displacement are used as the offset for computing the 20 bit physical address. Next segment register is the stack segment register. As we all know, the stack is the location assigned in the memory for temporary storage. This stack segment register is again a 16 bit register. It points to the current stack position. The 20 bit physical address is calculated from the stack segment and the stack pointer. Here the segment register is the SS and the offset address is defined by SP, that is the stack pointer, for stack instructions such as push and pop. In based addressing mode, the 20 bit physical address is calculated from the stack segment and the base pointer register. Now the next segment register is the extra segment register. As the name suggests, extra, it is used for storing the data which has not been stored in the data segment due to shortage of this space. Again, this extra segment register is a 16 bit register. It points to the extra segment in which the data in excess to 64K pointed to by the DS is stored. The string instructions use the ES and DI to determine the 20 bit physical address for the destination. Now the next register is the instruction pointer register. As we all know, in 8085 microprocessor there is a register called program counter. It is responsible for the holding the address of the location from where the next byte is to be fetched. Similarly, in 8086 microprocessor we have a 16 bit register known as the instruction pointer register or IP register. It is again a 16 bit register. It always points to the next instruction to be executed within the currently executing code segment. So this register contains the 16 bit offset address pointing to the next instruction code within the 64 kilobyte of the code segment area. Its content is automatically incremented as the execution of next instruction takes place. Now let us see some another components of the bus interface unit. The important component is a 6 byte prefetch queue, a group of first in first out FIFO in which up to 6 bytes of instruction code are prefetched from the memory ahead of time is known as a prefetch queue. This is done in order to speed up the execution by overlapping the instruction fetch with the execution. This mechanism is known as pipelining in 8086 microprocessor. This feature was not supported in 8085 microprocessor. Due to this pipelining, the 8086 speed up the execution of the instructions. Now let us come to the next component, that is the execution unit of 8086 microprocessor. The execution unit decodes and executes the instruction. The decoder in the execution unit control system translates the instructions. The main components of execution unit are the general data registers, that is AX, BX, CX and DX. The pointer registers, that is SP stack pointer register, BP base pointer register, DI, destination index register, then SI, that is the source index register. Then this execution unit has temporary registers. Then ALU, ALU is the arithmetic and logical unit which is responsible for performing the various arithmetic and logical operations in 8086 microprocessor. Now these general data registers, that is AX, BX, CX and DX, can be used as 8-bit registers also. Like AX can be used as AH for 8-bit operation or AL as a 8-bit operation. Similarly, BX can be used as BH and BL for different 8-bit operations. CX can be used as CH and CL again for 8-bit operations, and DX can be used as DH and DL for various 8-bit operations. Here H represents the higher byte and L represents the lower byte. Now let us discuss these general data registers in detail. The first one is the register AX. It is also referred as accumulator register. It consists of two 8-bit registers, namely AL and AH, which can be combined together and used as a 16-bit register AX. AL in this case contains the lower byte of the word and AH contains the higher byte of the word. The IO instructions use AX or AL for inputting or outputting the 16-bit or 8-bit data to or from an IO port. It means the AX or AL are used as 8-bit port or 16-bit port for performing various IO related operations. Multiplication and division instructions also use the AX or AL. As we all know, in 8085 also the accumulator or A register was always involved in performing arithmetic and logical operation. It used to store one of the operand for performing arithmetic or logical operations. Now the next general register is the BX. It is also referred as base register. It consists of two 8-bit registers, that is BL and BH, which can be combined together and used as a 16-bit register, namely BX. BL in this case contains the lower order byte of the word and BH contains the higher order byte. This is the only general purpose register whose contents can be used for addressing the 8086 memory. This BX register is the only register in general data registers which can be used for different addressing modes in 8086 microprocessor. All memory references utilizing this register contents for addressing use DS as the default segment register. So whenever BX will be used in particular addressing mode, the segment will be the DS or the data segment by default. Now the next general register is the CX. It is also known as the counter register. It again consists of two 8-bit registers, that is CL and CH, which can be combined together and used as 16-bit register CX. When combined, the CL register contains the lower order byte of the word and CH contains the higher byte. The instructions like shift, rotate, loop use the contents of CX as a counter. For example, during the execution of the loop instruction, when this instruction starts executing, for each cycle of execution CX is decremented by 1 without affecting flags and will check if CX is 0. If it is 0, 86 executes the next instruction, otherwise the 8086 branch to the label start. This start is nothing but the label, or we can say the beginning of the loop, and it will be continuously executed unless and until CX becomes 0. Now the next general register is the DX or the data register. It consists of two 8-bit registers DL and DH, which can be combined together and used as 16-bit register DX. When combined, DL register contains the lower byte of the word and DH contains the higher byte. This dx is used to hold the high 16-bit result in case of 16-bit multiplied by a 16-bit or the high 16-bit dividend data before a 32-bit divided by 16-bit and 16-bit remainder after the division. These are the uses of DX register. Now, the some another registers, or we can say some another important registers of execution unit are the SP, that is stack pointer register, and the BP, that is the base pointer register. SP and BP are used to access the data in the stack segment. It means these two registers are used as offset for defining the address in the stack segment register. SP is used as the offset from the current stack segment during the execution of instructions that involve the stack segment in the external memory. SP contents are automatically updated, that is either incremented or decremented due to execution of push or pop instruction. The push instruction is used to store the data on the stack, while the pop instruction is used to retrieve the data or to take out the data back from the stack. The BP contains an offset address in the current stack segment which is used by the instruction utilizing the base addressing mode. Now, some another important registers of execution unit are SI, that is source index register, and the DI, that is the destination index register. These registers are used in the indexed addressing mode. The instruction that process the data string use the SI or DI register together with the DS and ES respectively in order to distinguish between the source and the destination addresses. Actually, these two registers, that is the source index register and the destination index registers, are used for string operations. Strings are nothing but the collection of similar type of data stored in the memory on the consecutive memory locations or the continuous memory locations. So, whenever we have to access the string, we go with these registers. Now, let us summarize these registers in a single table. First one is the general purpose registers. It includes AX, BX, CX and DX when we are using them as 16-bit registers, or we can say AL, AH, BL, BH, CL, CH and DL, DH when we are using them as the 8-bit registers. Now, second is the pointer registers. In it we include two registers, that is SP and BP. SP is the stack pointer register, BP is the base pointer register. These both are 16-bit registers. Third one is the index register. It again includes two registers, that is SI source index register and DI, that is the destination index register. Again these two are 16-bit registers. Next we come to segment registers. Segment registers include CS, that is code segment, DS, that is data segment, SS, that is the stack segment, and ES, that is the extra segment. All these four are 16-bit registers and are used to hold this segment address. Then next we have the flag register. It is also known as PSW, that is the program status word. Flag register, as we have already discussed in the last lesson, it includes 9 flags, in which 5 are the same as they were in the 8085, that is sign flag, carry, 0, auxiliary carry, parity, and the 4 new flags introduced in 8086 are trap, interrupt, direction and overflow. Now, we can summarize that the registers of 8086 are very much useful for programming, and each register of 8086 has some special function which has been tabularized. The AX, it is a 16-bit accumulator. It stores the 16-bit result of arithmetic and logical operations. AL, again a 8-bit accumulator, stores the 8-bit result of arithmetic and logical operation. BX, that is the base register, used to hold the base value in the base addressing mode to access the memory data. CX, count register, it is used to hold the count value while the execution of shift, rotate and loop instructions. DX, data register, it is used to hold the data for multiplication and division operations. SP, that is the stack pointer register, it is used to hold the offset address of the top of the stack memory. BP, that is base pointer register, it is used to hold the base value in base addressing using stack segment register to access the data from the stack memory. Then SI, that is source index, it is used to hold the index value of the source operand or data for string instructions. And DI, that is destination index, it is used to hold the index value of the destination operand for string operation. So this is all about the architecture of the 8086 microprocessor. So friends, today we have discussed about the internal architecture of 8086 microprocessor. We have discussed that the internal architecture has two components, that is bus interface unit and the execution unit. Then we have studied about the various components which are available in the bus interface unit and which are available in the execution unit. And we also discussed how a 20-bit address is calculated by the adder circuit in 8086 microprocessor with the help of two 16-bit registers, that is segment register and the offset register. I hope you all have enjoyed this lecture.